अच्छा, can you guys hear me? आवाज आ रही है?
Yes, sir.
Okay. So I'm gonna just quickly start with the homework that we were doing. You just had to draw these electrodes. So I'm going to start with the first one, which is this one, the H2O2 one, right? So this one had a gas, and the other ions were aqueous. Hydrogen peroxide is also it's probably going to be aqueous as well. Okay, so that means the electrode would kind of look like this. There's going to be a solution. The solution is going to contain all your ions. The ions are what? Your first equation. It's H+1, and the other stuff that's going to be present in the solution is H2O2. And then there's H+1. Highlight correct. There's H+1, there's H2O2, and you need oxygen as well. So I would add a gas jar. ठीक है, तो let me draw. So I guess that kind of looks like a gas jar. And the gas jar will have what? Oxygen gas. So whatever happens, whoever wants to gain electrons or lose electrons, whether the reaction goes forward or backward, they're going to lose and gain electrons on a platinum electrode. So your electrode is going to be your platinum electrode. अच्छा हुमैद, वो mistake जो थी ना आपकी, that's you did not write H2O2 in the first one, ठीक है? The first one that you did.
Okay, sir.
So the other one, that's kind of exactly the same. That's the first one. The second one is almost exactly the same. So I'm going to just copy this. इसको shrink कर लें. So the second one is you still need oxygen gas, so you still have वो जो gas jar है ना, you still have that. So you still have the oxygen gas coming in a gas jar. So that's plus you need water, though you don't write water because the solution is already water, right? The solution is going to have these ions, HO2 minus 1 and OH minus 1. Those are going to be your two ions. So I'm just going to change that. I'm going to rub this off. The ions that are present in the solution are HO2 minus 1. And you got OH minus 1. Okay, so, and then they're going to have some reaction. And it's going to build some potential, and that's going to be this one. अच्छा, फिर next one, the lead and lead ion. That's a metal and metal ion electrode, right? So that's the first type that we did. Okay, let's just redraw this. So the third one, that is simply lead ions in the solution, and you'll have a lead metal electrode. Or so that's it. Okay, that's the third one. ठीक है, इसके ऊपर लिख लें एक सेकेंड. And then you have the fourth one. The fourth one is only ions. So you have a solution that's got ions. So all your ions will be part of the solution. So you'll have Pb2 plus and Pb4 plus, all part of the solution. And now where would they gain or lose electrons? For that, you would need to add a platinum electrode. Okay, so that's your number 3, number 3, and that's number 4.
Now for the second one, are we gonna add the H2O?
Second one,
Yeah.
you don't write H2O because it's obviously understood that the solution is water, right? I mean, you can just write H2O, but that, I mean, it's kind of obvious that it's an aqueous solution. Okay, Sina, is this clear?
Yes, sir.
So that's all about drawing. Okay, now yesterday what we did was we just a quick recap that I explained to you that if a substance likes to gain electrons, the electrode will become positively charged or will have a higher potential. But I explained to you that don't look at the positive or negative values. Instead, just look at the higher or lower potential. Okay, ignore the signs, ignore the positive and negative. The values themselves, they don't really mean anything. Okay, it's just higher and lower. So you're going to have, if substance likes to gain electrons, the electrode will be electron deficient because the substance would gain all the electrons and it will be positively charged. Vice versa, if the substance likes to lose a lot of electrons, the electrode will have a lot of electrons in it and it's going to have a lower potential. Okay, main idea. Then we did that what you can do is you can connect two electrodes together. When you connect two electrodes together, then you have a redox reaction. What happens when you connect two electrodes together? There's going to be one electrode which is going to have a higher potential, and you're going to have another electrode which is going to have a lower potential. Okay, ignore the signs, just higher and lower. Okay, just higher and lower. And the electrons would flow from the lower towards the higher side. The higher one would gain electrons because the electrons would be coming towards it. It would start gaining electrons, so it would undergo reduction. The higher it always undergoes reduction. While the lower one is the one that's losing electrons. It was the lower potential because it wanted to lose electrons. So now it's got an opportunity to lose electrons. So the lower one is always going to undergo oxidation. And so now you have a redox. So the reaction is not going both ways now. The higher potential would only gain electrons. The lower potential would only lose electrons when you connect two electrodes together. So reduction, and this is oxidation. I've written this equation in the backward direction because it's losing electrons. I've written this equation in the forward direction. Why? Because it's gaining electrons. You can add up the two equations together. Add up the reactants, Ag plus 1, Na, that's on the left side, Ag and Na plus 1 on the right side. Make sure your electrons gain and lost are equal. Okay, these are your two half equations. These are your two half cells. And this entire thing is now your complete electrochemical cell. Reason you call it a cell is that now you have energy being produced. A cell produces electrical energy. Okay, electrons are moving from one half cell, one electrode, to another electrode. So it converts chemical energy into electrical energy. That's what a cell does. And I told you that the greater the potential difference, that's E naught cell, that's higher potential minus lower potential, or the way you calculate potential difference in physics. The bigger the difference in potentials, the bigger the voltage over here, the faster the reaction. The electrons would travel much faster if this had been a higher potential. So E naught cell indicates how spontaneous the reaction is going to be. It's always reduction potential, the higher one, minus the lower one, which is the oxidation potential. So technically it's reduction E naught minus oxidation E naught. And this gives you a very high potential. So that means this reaction, the one that we wrote over here, that's very, very That's very, very feasible, ठीक है? So is this clear?
Yes, sir.
सारों को clear है? Tasneem, is this clear? Ahmed, Saad?
Yes.
Yeah.
So, so next is we're just going to practice this, okay? The only thing I think I did not explain earlier was the only thing that we didn't do was the salt bridge, right? Why is a salt bridge necessary? So salt bridge is it's needed to complete the circuit. So it's needed to complete the circuit, and without it, no current would flow. And I will explain to you why. What really is a salt bridge? That's it's basically it contains ions. Uh, and movable ions. I mean, not really movable. It could be in the form of a gel. As long as diffusion could happen, they can sort of move around. So it's either aqueous or in some form of gel form where diffusion could happen. Now, this is what the salt bridge does. So what did I tell you about the reaction? The lower potential loses electrons, right? Because the electrons are traveling to the other side. So the lower one is the one that's producing all the electrons. It likes to lose electrons. Oxidation happens. Now, if the lower one is losing electrons, what is changing? What is happening? Na is getting converted into Na plus 1. So that means a lot of Na plus 1 ions are getting produced. So what is happening is in the right half cell, on the right hand electrode, a lot of sodium ions are getting produced. And so your solution is becoming more and more positively charged, right? So what happens if it becomes too positively charged? If it becomes too positively charged, then it will stop the electrons from going to the other side. It will attract the electrons itself. Why would it send the electrons to the other side if there are too many ions, too many positively charged ions in the solution, then the electrons, instead of going to the other side, the negative electrons are going to get attracted to the solution itself, right? So the current would stop flowing. ठीक है, तो ये idea clear है कि if the amount of ions increase, current stops. Is that clear?
Yes, sir.
So what the salt bridge would do is that it's like a diffusion channel. What it would do is that the extra ions that are getting produced, they all start diffusing into the salt bridge. Diffusion happens. The ions move from a region of higher concentration to a region of lower concentration, right? So even though the reaction is going on, but your ions in the solution are not, they're not increasing by a huge amount. So that's why the electrons keep moving to the other side, the higher potential. Is that clear what the salt bridge is doing on this side? Is this clear?
Yes, sir.
और बाकी के next one is what does it do on the other side? It does the opposite, right? What is happening on this side? The higher potential gains electrons, silver ions turn into silver. So the amount of silver ions, they're decreasing because they're all turning into silver. So if the solution initially had a lot of silver ions, let's say initially it had a lot of silver ions, Slowly, those silver ions are going to get used up because when the electrons travel from the other side, the silver ions, they get converted into silver. So the silver ions are slowly being used up. So what the salt bridge would do is, because the silver ions were the ones that were gaining electrons, right? So you need more silver ions. So the salt bridge would probably contain a salt that contains silver ions, and those silver ions will start diffusing out into the solution because you would need more silver ions. तो आपका ना यहाँ पे सिल्वर आयंस जो है ना वो ज्यादा होना शुरू हो जाएंगे. ठीक है, so it kind of balances the ions. So it's like completing the circuit. It does not let the sodium ions increase over here. They get diffused into the salt bridge. And on this side, it does not let the silver ions decrease. So more ions diffuse out of it. I mean, that's how basically your battery works. After a certain point, I mean, if you open a normal battery like remote cells, etc., they all work in this way. After a certain point, the battery stops producing current. Why does that happen? Because your salt bridge basically gets used up. If you have too many sodium ions over here, the electrons would not move to the other side. And if you run out of silver ions, then there would be no one here that would be gaining those electrons. And so basically the whole circuit is going to be turned off. So it all depends on the salt bridge. If it gets used up or gets damaged, the battery just stops working. Okay, is this clear? Importance clear? Why the salt bridge is necessary?
Yes, sir.
Yes, sir.
अच्छा, और फिर दूसरा ये भी बता दो कि the salt bridge is not really that important. Okay, I mean, this whole thing, no one is going to ask for an explanation for this. Maybe they would. So far, no one has ever actually questioned. I mean, the salt bridge has to be there. Okay, just remember that. Up till this point, up till 2023, not a single question on this. So not really important. But still, you can actually get a question on this. So, what we'll just do is we'll connect random electrodes, and we'll try and figure out their potentials. As I missed out one important thing. Okay, we did talk about the electrochemical cell, right? So there's one very important thing that we have missed. I mean, we've covered actually most of the basic stuff, right? But the thing has to do with drawings. So I told you that you connect two electrodes together. The higher potential gains electrons, electrons flow towards it. The lower potential, the negative one, produces electrons, electrons flow from the lower to the higher. This one gains, this one loses. That's the basic idea. Now, the thing that we have missed is about how do we measure the potentials? TK, I did explain to you that you can set up electrodes. वापस इसी पे आ जाते हैं. So you can set up electrodes and like this chlorine electrode. Chlorine likes to gain a lot of electrons, so it's very, very positively charged. But and it's got a higher potential, right? Now, when you measure potential, right? Or when you measure anything, like any measurement that you do, it always needs a reference point. Okay, like if you're measuring your height, so obviously you need a meter rule or something that's used as a reference, right? That something must be some standard something. Like you can measure your height in inches, so you should know what an inch is. Or you can measure your height in feet, or you can measure your height in centimeters or millimeters or whatever, right? But there has to be a reference. There has to be some sort of scale or something that you're measuring against. Okay, like you go to a shop and you measure something in kgs. So there has to be a reference, like what is a kg? So there's something that's defined as a kg, and you measure the things you've bought, the weight of something in comparison to that. So when you're measuring potentials, right? Just a height, when you measure heights, right? So what is taken as a reference? Like if you're measuring heights of mountains, you take the sea level as a reference. The sea level is considered to be 0, and then you figure out like how high you're from the sea level. Now the point is, how do you measure potentials? The potential of this electrode is measured against a reference. So this thing over here, you see this in physics as well, that's referred to as the ground or the earth. So in reality, circuits don't have any ground or earth. I mean, you see a TV, there's no, I mean, usually you don't see anything going into the ground. You've got a mobile, you got a circuit, there's nothing attached to the ground. So this is your 0 potential. That's your reference. The reference itself is always 0. The sea level has a height of 0 meters. Anything higher than that or lower than that is measured compared to that. So what you do in electrochemistry is that you got so many electrodes that you pick one electrode as your standard reference electrode. And you measure all the potentials against that particular electrode. Okay, let me show you what that electrode is. So out of all the electrodes that you've made, you would notice that all of them have values. Some of them have higher potentials, some of them have lower potentials, right? But compared to what? So that compared to what is, come up here, I'm pretty sure you can spot 0 somewhere. It's this one. Do you get that? So that's another electrode that is assigned 0 potential. So you basically don't measure its potential. You measure all other potentials against this particular electrode. So either those other electrodes will have a more negative potential or a lower potential compared to this one, or they would have a higher potential like plus 1.49 compared to the hydrogen electrode. So all electrodes, their potentials are measured against this particular electrode. Okay, is this clear? ये बात clear है how the potentials of the other electrodes are measured?
Yes,
Yes,
sir.
sir.
So this thing over here, this earth, that's basically an electrode. And all electrodes, when you have to measure standard electrode potentials, they're measured using a standard hydrogen electrode. So let me define this. It's the same concept, nothing new. So they're going to ask you the definition of the standard electrode potential. This is going to come as a definition. So it's the potential difference of a standard electrode measured against बल्कि between होगा, sorry, potential difference between, this would be between between a standard electrode measure and a standard hydrogen electrode. Measured under standard conditions. So let me make a complete diagram now. So if I were to measure a iron lead electrode potential, then I'm going to measure it. You want to copy. in comparison with a hydrogen electrode. So the hydrogen electrode is this one. It's 2H plus 1, gaining 2 electrons. So there is H2 gas, and there is H plus 1. The middle part, that's your platinum electrode, and you're going to connect them together. And there's going to be a voltmeter between them. Okay, so this is your reference electrode. So basically not measuring the potential of the hydrogen electrode, that's always considered to be as 0 volts. Whatever potential appears on this, which we've already calculated, that's, it's already given the lead, over here. That's minus 0.13 volts. So basically, you measured the potential of the lead ion electrode against this standard hydrogen electrode. And you figured out that it had a lower potential, a slightly lower potential. It was minus 0.13 volts compared to this one. So every potential is measured against this reference electrode, and there's one thing missing, and that's your salt bridge. So there has to be so that's a salt bridge. The equilibrium on this side was basically this one, Pb2 plus 2 electrons in equilibrium with. ठीक है तो ये. So you'll be asked to draw this, and so remember the standard hydrogen electrode. ठीक है, if they ever ask you and that's going to be our reference. ठीक है, ये clear है? Is this clear?
So if they ask to draw a standard one, so we have to include the hydrogen one as well, or just the standard one?
And if they ask you to, for example, the question is going to be if they ask you to draw a diagram to measure the electrode potential of the lead ion electrode, right? जो भी हमने किया था, so lead ion electrode. So how do you measure it? You measure it by comparing it with the hydrogen electrode, which is this one.
Okay, sir.
ठीक है, बाकी clear है? Ahmed, Saad, is this clear? Harun, clear?
Yes, sir.
Yes, sir.
ठीक है. अच्छा, so अभी तक ना we just fixed with drawings. ठीक है, just remember again the idea is higher potential gains electrons, lower potential loses electrons, right? Between the two, अच्छा इसका वैसे कर लेते हैं, ठीक है? Where would the electrons flow if you connect these two electrodes together? Left to right to left?
Left to right.
ठीक है, electrons flow towards the higher potential, which is this one. This one is your lower potential. So electrons always flow towards the higher potential, and so it's going to be left to right. So that means this side, if you connect the two electrodes together, then it's no longer going to be a reversible reaction. The left one is the lower potential. It would start losing electrons. So its reaction would start going in the backward direction. It would start to lose electrons. And the right one is the one that's going to gain electrons, because all the electrons are coming towards it. So it will start to gain electrons. So the higher potential gains electrons. So gains electrons, and अच्छा उल्टा लिख दिया. Gains electron is reduction. वो वाला जो है, that's not reduction, that's actually oxidation. And you can come up with an overall equation based on this. Okay, what are your two half reactions? The lead is the one that's losing electrons. It's turning into lead 2 plus. This side, lead turns into lead 2 plus. That side, H plus 1 turns into H2. So that's forward direction. It's 2H plus 1. And you can now add them up. But make sure the electrons gain and loss are equal. So add the left side, the reactant. So it's lead plus 2H plus 1. And what is your right side? Your products in the two reactions. The products in the two reactions are lead ions are getting formed, and you got H2 gas. And you can calculate the E0 cell as well. That is higher potential or reduction potential minus oxidation potential. So it's the higher one, that's 0 volts, minus your lower one, which is minus 0.13 volts. And this comes out to be plus 0.13 volts. So that's a very low value. So that means the reaction will probably happen, but it's not that spontaneous, not very spontaneous. Well, last time, yaad hai ki kya tha? Last time we had an E0 cell of 3.51 volts. So that was a very vigorous reaction. The electrons, the potential difference between the two electrodes was extremely high. But not in this case. Not in this case. The electrode potential is not that high. So यहाँ पे it's just एक second. यहाँ पे it's just 0.13 volts. So not very spontaneous. I mean, it's barely feasible. अगर दोनों का 0 होता ना, then there would have been no reaction. The electrons would not be flowing. ठीक है. अच्छा, so ये clear है ना? This part, is this clear that what is a reference electrode? What does that mean?
Yes.
Yes, sir.
ठीक है. चलो अब ये कि बस मेन तो हो गया. ठीक है. That's about it. What we'll just do is, I mean, just up till the drawing part. Okay, we're done with the drawing stuff. We'll just carry out. बस ये draw करने में बहुत time लग जाता है. So we'll just अभी ना we'll just in the next classes we'll do exactly the same thing, but now without the drawing. Without the drawing, things are pretty easy. Like if I didn't have to draw this, it would have been very easy for me to actually just write the reaction. I would have known, okay, this is the higher potential, so it gains electrons. This one is the lower potential, so it loses electrons, and that's about it. Okay. So without the drawing, things are like fairly easy. When you have to draw everything, then you have to be careful about everything. Without the drawing, coming up with the equation, coming up with the E0 cell, that's pretty easy. So I'll just do some other examples. So let's say I've got, so let's say there's a very popular reaction, which is this one. It's an Fe3 plus Fe2 plus electrode versus plus a KMnO4 electrode. So MnO4 -1 acidified in equilibrium with Mn2 plus. So I'm gonna try and construct these two electrodes. Like let's just now both electrodes are of the same type because they only have ions. So it's basically a solution that contains ions, and that solution will have a platinum electrode dipped into it. Okay, so the other one is kind of exactly. So that's exactly the same. So this one has Fe3 plus. और ये वाला जो है that's your MnO4 -1 and H+1 all present in the solution. Just connect the two together. It's a voltmeter. Just let me. बस ये ड्राइंग में थोड़ा टाइम लगता है ज़्यादा होता है. So ये 20 में salt bridge and that's your voltmeter. ठीक है, so the drawing is complete. अच्छा, what were the electrodes? I'll just refer to the data booklet. So Fe3 plus, Fe2 plus. Where's the reaction? This one. It's this one. Okay, we already know what the potential is. 0.77 volts. Okay, so let me just write down the equation. So I got Fe3 plus. And this one has the higher potential. Sorry, it's 0.77 volts. What's the other one? The MnO4 Mn2 plus electrode. So I need to find that out. That's over here. It's this one. It's 1.52 volts. So it's 8H plus 1 Mn2 plus 4H2. Okay, let's just copy that. तो क्या था MnO4 -1 and this one is 1.52 volts. ठीक है, so यहाँ तक clear है? Is this clear? Drawing clear है?
Yes, sir.
अच्छा, अब बस quickly now the next part, which is where would the electrons flow? Left to right, right to left?
Left to right.
Left to right.
So ठीक है, so left to right. So the electrons would flow left to right. This one is your higher potential. Higher gains electrons. So that's electrons are coming towards it. So it's going to gain electrons. So it's going to have more electrons. So the forward reaction would be favored. It will start gaining electrons. And that other one, that's your lower one. Lower जो है, that's your reduction. Sorry, your oxidation. फिर गलत कर दिया. That's lower is your loses electrons, oxidation. So it will start to lose electrons. So that's going to go in the backward direction, right? So that's about it. Okay? Without the drawings, things are easy. Higher gains, lower loses, right? And you can come up with the overall equation. Okay? The two half cells or half reactions, reduction and oxidation, you can just combine them. So yeah, Fe wala ulta hai, so that's Fe2 plus turning into, it's Fe2 plus turning into what? Fe3 plus. Goes in the backward direction, loses electrons. The other one is in the forward direction, gains electrons. So that's MnO4 minus plus 8 H plus 1 plus 5 electrons. Okay, Mn2 plus 4 H2O. And you just add them up, okay? But before adding them up, the electrons gain and loss, they have to be equal. So I'll multiply this by 5. Well, there was 1 electron lost and 5 electrons gained. So I multiplied the first one by 5. Open in Saroguna, you just combine them. Okay, now this is, so there's going to be 5 Fe watt 2 plus and MnO4 minus 1 plus. In the product side, there's going to be 5 Fe3 plus so that's my overall reaction. So I was able to come up with the entire redox reaction by just figuring out higher gains and the lower one loses. And I can write the E0 cell as well, which is what? Higher potential minus lower potential, or reduction potential minus oxidation potential. So it's 1.52. कितना आता है 1.52 minus 0.77? What do you get?
So 0.75.
So you're getting, so we're getting 0.75 volts. So that indicates how fast this reaction is going to be. I say ये जो reaction है, this is it often appears in your titration questions, redox titrations, KMNO4 with iron ions, ठीक है? अच्छा, तो अब drawing नहीं करेंगे, ठीक है? From now on in the next class, we'll not be doing drawings, ठीक है? But remember, drawings are important because they carry a lot of marks, ठीक है? You get big questions, maybe 5, 6, 7 marks, ठीक है? Just on the drawing, ठीक है? So that's why drawings are important. You have to get the drawing right. But otherwise, the concept is pretty simple. You get 2 electrodes, you just see the equation, 2 equations, you see one of them having a higher potential that gains electrons. You see the other one having the lower potential that loses electrons, that's it. And you can come up with the redox reaction very, very easily, ठीक है? Clear है? कोई question नहीं है किसी का? सब कुछ clear है?
Yes, sir.
Yes.
ठीक है. चल ठीक है, फिर we'll continue. I'll send you some questions and some homework as well, ठीक है? So ठीक है, Hasina, are you there? चलिए ठीक है, next time continue करते हैं. Hasina, let's start in 5 minutes, ठीक है? Chale. Okay. Everyone take care.
Thank you, sir. Love it.
Hafiz.
love.